Hello everyone. Acute exposure means exposure via oral route, either a single administration of a chemical or a single dose, or repeated exposure for less than 24 hours of period. If it is for inhalation exposure, generally acute duration is for less than 24 hours, but usually the studies are conducted for 4 hours duration. Subacute exposures are usually less than or equal to 1 month of repeated exposure. Subchronic is usually between 1 to 3 months of exposure. And for chronic, it is greater than 3 months. Usually the chronic studies are conducted for 1 year of continuous exposure. This is, these durations are for the animal studies. But in case of workplace, or environmental exposure, acute means a single episode or a single incident of exposure. Okay, subchronic is a repeated exposure or a continuous exposure for weeks to months. Similarly, the chronic exposure is a repeated exposure for months to years. In 1984, methyl isocyanate was leaked from a factory in India, in Bhopal. And because of that, around 200,000 people had acute exposure to this chemical, and this resulted in 2,000 deaths in first 24 hours. Okay, this is one example of acute exposure to a chemical. If high levels of lead is continuously given to children or workers, this happened for weeks to months, which is what? Subchronic exposure. Subchronic exposure in case of environmental exposure or under work settings leads to neurological effects. That means at least this duration, weeks to months of continuous lead exposure, is required for these neurological effects to be manifested. We know that ethanol causes liver cirrhosis, and cigarette smoke causes COPD. These liver cirrhosis and COPD from these chemicals or a mixture of chemicals would take years to develop. Okay, so chronic exposure to either ethanol or cigarette smoke is required to produce toxic effects such as liver cirrhosis and COPD respectively. Benzene has both acute and long-term effects. As an acute effect, whenever someone is exposed to benzene, CNS depression will happen. But benzene, upon repeated or chronic exposure, causes bone marrow suppression. And also increased leukemia risk. If for a chemical, T half is equal to frequency of dosing, then theoretically toxic concentrations won't be reached until the fourth dose. In repeated dose toxicity studies, the toxicity of a chemical depends entirely on frequency of dosing rather than duration. This is very important point. At greater than 150 mg per liter of blood levels, acetaminophen is toxic in general within few hours. Individual dose response or graded dose response is a dose response curve that is constructed in individual organisms, or depending on how an individual response. Whereas quantal dose response curves are dose response curves constructed based on responses of population. That means these are all or none type of dose response curve. These will measure either a certain individual is responding or not. Or these are also can be called as the measure of accumulation of individual responses. Or low dose effects. For dioxin, TCDD. For dioxin, aryl hydrocarbon receptors are activated at low dose, but such activation is less evident at high dose. Graded dose response or continuous scale dose response curves are used for evaluation or identification of specific biochemical processes. For example, chlorpyrifos, in rat brain causes acetylcholinesterase inhibition at 3 mg per kg dose level. At the same dose level in the rat liver, chlorpyrifos show no effects on carboxylesterase. But at 5 mg per kg dose level in rats, both enzymes, both acetylcholinesterase and carboxylesterase are inhibited. But acetylcholinesterase is, at somewhat inhibited at somewhat greater extent. Such biochemical responses are measured using graded dose response curves or continuous scale dose response curves. LD50 values or lethal dose 50 values give ballpark indication of poisoning from single exposure. Ballpark indication this will provide. Now let's see about quantal dose response curve. Quantal are all or none dose response curves. So these will measure the responders versus non-responders based on the data collected. Usually these dose response curves fall under normal frequency distribution. Or Gaussian distribution. If we plot responders versus dose, this is how the dose response will look like. The responders at the far left are hyper reactive or hyper susceptible, and responders at the far right are resistant to particular chemical or particular effect. Such normal distribution curves can be converted into sigmoid dose response curves, which can be used in experimental biology very frequently. Threshold dose is minimum effective dose for evoking stated all or none response. It is minimum effective dose to evoke all or none response. Conversion of normally distributed population data points to log values, okay, that is dose to log dose, will result in straight line of the graph. But usually result in straight line, but not always the straight line. For some responses such as radiation effects, probit fit is used rather than the log conversion of doses to log value. And probit fit, for the probit fit, arithmetic values are directly taken. For dose responses, usually for normally distributed population, various trial and errors are tried to get the better fit of the line. If probit fit is not working well, then hill or log it or Weibull methods can also be used. For normally distributed populations are under Gaussian curves. If we convert that into a sigmoid curve, between 16 to 84% we will see straight line. Which is also correspond to limits of one standard deviation of mean. But this would not always be the case because of some limitations with the data, such as low sample size, or responses at high or low doses. Similarly, in normally distributed population curves, mean plus or minus one standard deviation would cover 68.3% under graph, or 68.3% of all responses. Plus or minus two standard deviation would cover 95.5%. Plus or minus three standard deviation would cover 99.7% of all area under graph. One very important point here is NET, which is normal equivalent deviations. These are nothing but units of deviations from mean. Certain units of deviation from mean. Usually normal equivalence, equivalent deviation for 50% of response is 0. Okay, NED plus 1 would be 84.1%. And conventionally NED plus 5 is used to avoid negative values, and these are converted to probit units, which are nothing but probability units. As we have already discussed, the conversion of bell or sigmoid shape to probit units or probability units will result in straight line. So from that we can make out that 50% of response correspond to probit of 5 plus 1 deviation is probit of 6, and a -1 deviation is probit of 4. From these straight lines, one can calculate ED10 or ED90 or any level of response for that matter. This can be achieved simply by drawing an horizontal line. A horizontal line from probit of 5 would result in ED50 value. Similarly, horizontal line, depending on the deviation, +1, -1, we can obtain the any effective dose level. Allometry is used for extrapolation of doses across species. Extrapolation of doses across species. And this is also known as a field that measures the relation between body weight and other biological parameters. These may include basal metabolic rate, heart rate, blood flow, etc. For any biological parameter of interest, let's say y, if y has certain constants a and b, that means these constants a and b are constants of this biological or bio parameter of interest. Y equal to a into w power b. Okay, w is body weight. Using this formula, the organ sizes between various species fit better or the scale best when the constant b is equal to 1. Similarly, the metabolically derived parameter scale best when constant b is equal to 0.67 or 0.75. So there is one simple approach proposed, which is use of BSA or body surface area rather than body weight to estimate across species. So surface area in this case is equal to 10.5 into body weight in grams power 0.67. Okay, these some new exponents were proposed for this formula, such as 0.73 with 95% confidence bound values, that is range from 0.69 to 0.77. So these values or these new exponents were proposed based on the data set of 27 chemotherapeutic drugs tested on mouse, rat, tested on mouse, rat, hamster, dog, monkey, as well as humans. And there are many applications for using allometry. For example, FDA recommends use of FDA recommends calculating maximum recommended starting dose in humans or first in human clinical trials. Using animal data, using allometry, and also safety factors. Okay, so how FDA recommends setting up the first in human clinical trial dosage using animal data, allometry, and safety factors. Noel from animal studies can be converted into human equivalent dose using body surface area. Human equivalent dose is equal to animal dose into animal weight in kgs by divided by human weight in kgs. Everything is power to 0.33. Okay, so using this formula, the animal Noel can be converted into human equivalent dose. Human equivalent dose is equal to animal dose in mg per kg into animal dose, animal weight in kg, human weight in kg to the power 0.33. One point to remember is not all toxic effects scale similarly across species. For example, acute lethality scale better when body weight rather than body surface area was used. For acute lethality, use of body weight scale better across species. Okay, and also use of allometry is more amenable for those that undergo renal excretion rather than biliary route excretion. So those that involve minimal hepatic metabolism are more amenable for use using allometry. Apart from allometry, PBPK or PBPK can also be used for dose scaling across species. PBPK uses key physiological parameters as well as mechanistic data to mathematically predict disposition of chemicals. Monotonic dose response. So this is a type of dose response in which increase in dose would result in unidirectional change in response. This will result in unidirectional response. For example, either uphill or downhill nature. These can be seen in certain chemicals such as butadiene, chemical activation of butadiene, methylene chloride, detoxification of methylene chloride, acetaminophen, co-substrate depletion, receptor interactions of hydroxyflutamide, vinyl chloride repair, manganese altered homeostasis. So these all are some dose dependent transitions, either saturable or inducible, dynamic or kinetic processes. Slopes may be different for along these dose dependent transitions. But all these would result in monotonic dose response. Similarly, non-monotonic dose response. In this type of dose response, there would be multiple inflection points along the curve that changes the shape. Non-monotonic would be biphasic, valley shape, U-shaped dose response curve, or hill shape, which is inverted U. Inverted U shape, either U shape or inverted U shape. Example for the chemicals that exhibit such non-monotonic dose response curves are essential nutrients, hormetic effect or hormesis is a concept in which the chemicals confer benefits at low doses, whereas harmful at high doses. And for some chemical, roller coaster dose response curves are also observed, in which the shape of the dose response keep on changing. They will have more up and down inflection points. Historically, these monotonic dose response curves are exploited for low dose effects by extrapolation of curves to low doses. Threshold is a dose at which the toxicity is first observed. That means below threshold level, 0 individuals would respond. 0 responders below threshold dose level. In case of linear non-threshold dose response, the response is proportional to dose even at low doses. For individual dose response relationships, threshold would certainly exist, but it is difficult to establish a true no threshold or no effect level. On this cover, for the chemical that have threshold, are plotted like this, and for the threshold, for the chemicals that do not have any threshold, linear and with no threshold, from the point, from certain response, minimum response, the dotted lines are connected to 0, that essentially show that at any given dose level certain response would be seen. For non-carcinogenic chemicals, TTC approach is used, which is a qualitative risk characterization approach. At TTC dose level, or below this TTC dose level, the risk to human health is minimal. And these thresholds are set based on the data from structure, exposure, disposition, metabolism, and toxicity of similar compounds or structurally similar chemicals for which there is some data. And based on this TTC, TTC means threshold of toxicology concern. Based on these thresholds, some chemicals can be prioritized for further testing. So there is something called ED01 study. This is a famous study conducted on 2-acetylaminofuran in 24,000 mice with 81 treatment groups. So this study was conducted to identify a statistically significant response of 1%. Statistically significant response, which correspond to 0.01 probability of response. In this study, liver and bladder tumors were increased. Liver as well as bladder tumors were increased with the dose, but shapes of two dose response curves are different. For liver tumors, there was no threshold. But in case of bladder tumors, threshold was shown. Even with the threshold, at 33 months of the study, the NOEL was 45 ppm whereas at longer duration 75 ppm was NOEL. Low dose tumor detection ability depends on number of animals. So we are not sure even if thresholds are established. If a large study is conducted with many number of animals, with an increased number of animals, one cannot surely say that tumors won't be seen. So that means there is a possibility that even under NOEL, tumors can be seen. In general sense, non-genotoxic carcinogens such as cloverblade, which is anti-hyperlipidemic or hypolipidemic drug, show thresholds, but for genotoxic carcinogens, no thresholds can be seen. Example for a genotoxic carcinogen is 2-acetylaminofuran. For ionizing radiations, upper confidence limits of lowest dose that causes cancers in humans. Was used for linear regression to zero intercept. Linear non-threshold risk modeling is a method used for risk characterization of ionizing radiation. However, the use of this method was criticized for not considering adaptive mechanisms such as DNA repair and the clearance of damaged DNA, clearance of cells with damaged DNA. However, new data sets generated using rainbow trout embryos with carcinogens calls for even stringent analysis of data for low dose curves. Genotoxic chemicals such as DBC, dibenzo, DFP, trizene show clear deviation from linearity at low dose. Low dose levels show deviation from linearity. And it crossed y-axis in 1 million of exposed animals. CTDOIM is an anti-carcinogen. It is related to some antioxidant in broccoli. So this CTDOIM prevent DNA damage and liver cancers in rats. Prevent DNA damage and liver cancers in rats. Treated with, even if rats are treated with aflatoxin B1. So this shows that ability of an anti-carcinogenic agent that has antioxidant properties. So the use of anti-carcinogenic agent to prevent the cancers caused by even the potent mutagenic carcinogens such as aflatoxin B1 shows that um, uh, adaptive responses play important role, and dose response not necessarily linear, non-threshold. Essential elements and trace elements usually show non-monotonic response. Via diet, the exposure to manganese is needed for bone formation and metabolism of macromolecules. Bone formation and macromolecule metabolism. So manganese is required. But if manganese is consumed in excess or ingested in excess, this will result in manganism, neurotoxicity resulting from brain accumulation of manganese. Okay, but at the same time, deficiency of manganese would result in seizures, impaired fertility, and growth delays. So this is one example of non-monotonic dose response curve. Excess of manganese would result in manganism, and the deficiency would result in fertility problems, seizures, and growth delays. So similarly, other trace elements such as chromium, cobalt, zinc, and selenium show U-shaped dose response curves. That means deficiency would result in problems, and at the same time excess would result in toxicity. So as we have already seen, hormesis is a concept, is an occurrence where some non-nutritional toxic substances, toxic subs that are not essential or non-nutritional, are beneficiary or stimulatory at low doses, whereas these are toxic at high doses. For example, radiation. Another well-known example is the alcohol consumption. Chronic alcoholism would result in esophageal, liver cancers, esophageal cancers, esophageal and liver cancers, as well as cirrhosis of liver at higher doses. Whereas at low doses, alcohol consumption would result in decreased incidence of stroke as well as coronary heart disease. So low to moderate consumption of alcohol. Okay, low to moderate consumption of alcohol results in decreased incidence of stroke and coronary heart disease. Similarly, TCDD would also show divergent effect. TCDD would cause promotion of altered hepatic foci, okay, which is a pre-neoplastic lesion that would lead to liver tumors in rodents. So TCDD at low doses would decrease the number of altered hepatic foci, whereas at high doses TCDD would significantly increase the number of hepatic foci. So the occurrence of hepatic foci can be detected by a marker, that is glutathione S transferase. So that is with such effects, TCDD would result in J-shaped curve, J-shaped dose response curve. Similarly, DDT, dichlorodiethyl dichloroethane, in rats at low doses decrease the baseline number of hepatic foci, whereas at high doses these hepatic foci are increased. Okay, so similar to TCDD, DDT would also result in J-shaped dose response curve. But so these are examples of hormesis or hormetic effect, but at low doses the magnitude of this response is modest, that is only up to 30 to 60%, which is not statistically significant. Similarly, the endocrine receptors or endocrine disruptors have effects at relatively low doses that are not seen at high doses. For example, bisphenol A with normal as well as cancerous prostate cells. Prostate cells in vitro. Would show biphasic centrosome amplification. Two to 8-fold. This show maximum inverted U shape. For endocrine disruptors, which we know this will have non-monotonic dose response. So the slope will change sign at least once in tested ranges. So low dose effects. What are low dose effects? Low dose effects are nothing but doses below OL, or effects that are shown below OL. So there was some evidence that phthalates show effects on the male reproductive tract development, as well as fetal exposure to di-2-ethyl hexyl phthalate, di-2-ethyl hexyl phthalate, di-2-ethyl hexyl phthalate resulted in decreased anogenital distance. Therapeutic index is equal to TD50 by ED50. So we use TD50 and ED50 instead of median dose because median has disadvantages. The main disadvantage is that the median dose do not reflect slope of dose response curve. Therapeutic index itself has some limitations. because it doesn't compare the variable slopes are not compared between effective and toxic dose response curves. So to overcome that, MOS was proposed. MOS is nothing but TD1 by effective dose 99. So MOS is nothing but margin of safety. For non-drug chemicals, margin of safety is nothing but exposure dose by NOAEL or other benchmark. Chronicity index is equal to 1 dose TD50 by 90-day dose TD50. If the chemical doesn't accumulate, no accumulation, then chronicity index would be 1. If accumulation occurs, it would be 90. Efficacy is extent to which a chemical elicits a response. So the efficacy is generally plotted on y-axis or ordinate. Potency is generally plotted on y-axis. Potency is nothing but a range of doses over which chemical produces a response. In 1965, Sir Aston Bradford Hill proposed several causations for a response. Okay, proposed that the causation can be established by following: strength of association and consistency of findings, specificity of association, temporal sequence, that means cause is followed by response, biological gradient, or biological or theoretical plausibility, as well as coherence with established knowledge. In addition, it was also proposed that the limiting exposure should result in decreased effect or disease. Evidence-based toxicology follow 3 methodologies. First one is to collect and evaluate data, collect knowledge and relevant literature. Third one is to conclude based on the data and knowledge collected. NTP coordinates the safety testing in federal governments. And precautionary principle. So this is one of the very important topics in toxicology. The purpose of precautionary principle is the protection of public's health and environment. Okay, so based on this, the regulatory restrictions that limit the human exposure are proposed. Even before the safety data, even before the occurrence of safety data. So by this precautionary principle, the burden of proof of safety is placed on manufacturer. To establish the lowest level of risk before commercial use. Action. At cellular level, key events are causal precursors. For example, DNA adduct formation, associated events, these are the events that are not required for mechanism, but can act as surrogate markers for occurrence of certain mechanism of action. Modulating factors such as reactive oxygen species formation or oxidative stress can change the outcome of certain mechanism of action. Okay, so key events, associated events, and modulating factors are important for considering mode of action. Adverse outcome pathways proposed in tox testing in 21st century initiative. Then ABP uses data from QSARs in vitro and in vivo Sources. AOP includes molecular initiating events, key events, as well as adverse outcomes. So AOP would include the study of response from MOE to population level. Population responses. Researchers can build adverse outcome pathways from AOP knowledge base of OECD. Selective toxicity means even though a chemical is nearby, the chemical is toxic to only certain cells or organisms. So the reasons for selective toxicity include the chemical may be equally toxic to both organisms or both cells, but selectively accumulates in one. Or one cell or one organism may have unique cellular or biochem factors that are absent in other cell or species. For example, radioactive iodine. It selectively accumulates. Radioactive iodine does selectively accumulates in thyroid gland. That's why it is used to treat hyperthyroidism as well as thyroid cancers. Similarly, bacteria cannot absorb folic acid. It has to synthesize folic acid from PAPA, paraminobutyric acid, glutamic acid, pyridine. But mammals can absorb folic acid. They can't synthesize it. Okay, so the sulfonamides are the chemicals. They resembles they resembles the PAPA. That's why they can stop the incorporation of PAPA into folic acid. That's why these sulfonamides are selectively toxic to bacteria. Thanks for watching.